But we've got to be productive for that to happen. That's how I'm being productive. Okay. Josh had questions, and that reminds me, so I'll make a list above, before I get going tonight, of things I'm looking for. So we took a test last Wednesday. If you were absent last Thursday, did I see your string activity? If you were absent last Thursday, did I see your string activity? Did you turn it in? Don't ask me if it was you or not. Don't ask me. If you were absent last Friday, we had a zombie exit slip. Some people have not gotten their exit slip because they were not here. If that is you, then when I get done rambling, come see me directly so you can get a zombie exit slip. And then today, everyone got points for the justification question because everyone had done the justification question. So everyone's getting 3 points today. It's 5 in the 30% category for doing the justification questions. Tonight, when we get done with this, I'm going to hand you, it's a coloring page on adding and subtracting. It's going to be due at the end of class tomorrow. About halfway through class tomorrow, I have to leave, and you'll be with Miss Deverly. You'll have an assignment, but if John David's productive, he could probably finish the coloring activity then and not have to do any homework tonight. But that means John David has to be productive during class today and productive during class tomorrow, and then he has no homework tonight. If that's not the case, John David's going to get, what's going to happen is John David's not going to turn it in, and then I'm going to tap in that 0 over the weekend, and then he's going to break my heart because it's going to end up mysteriously in that bucket on Monday, and I'm going to cry myself to sleep. I'm tired of things arriving late to me. Okay, so I can pick on John David. He won't do that to me. Okay. Everyone wrote down their learning target. I'm not talking about exponential functions anymore. Oh, but I forgot. Yesterday, we had an exponential function checkpoint. Did you turn in your checkpoint question? If the answer is no, make sure that gets in by tomorrow. When I check my drawer and leave for home tomorrow, it's the weekend. I tend to type in my zeros then. Okay. We're not talking about exponential functions anymore. We're going to talk about something new today. It is called a polynomial. Okay. I'm going to write on the paper as well as inside. A polynomial can have one term and be called a monomial, 2 terms and be called a binomial, 3 terms called a trinomial, and then it can have even more than that. So 1 is monomial, 1 term, 2 binomial, 2 terms, 3 terms trinomial, and it can have more than that. So the first thing you want to do when you get any problem is see how many terms you have. We call each little piece a term. See how many terms you have. So you want to count. You might have 8 terms. We don't have a cool name for higher than 3. But you want to count how many terms you have. And then you would say, Ms. Compton, how can you tell what is a term? How will we know the terms, like who's a term and who's not? That's a good question. Terms, and I'm going to write on the little flap. Terms are separated So I wrote terms are separated. Let me turn my paper so you can see what I wrote. Terms are separated by a plus or a minus. So you either see an addition sign or a subtraction sign. That's how you can count the terms. Okay, so when we open our flap, we're going to do some examples of each kind. So we talked about monomials, one term. So an example of one term would be x. X is a term. But so is 4x squared. That's a term. It's one unit all by itself. There's no plus or minus. 2x cubed. That's a term. Or we might even have a term with division. B divided by 4, that's a term. One term. A monomial. No. Okay, so a binomial has two terms. Yes, it does. A binomial has two terms. I can't do any for Natalia. More Natalia. Good grief. I'm sorry. So two terms would be like x minus y. Y plus 5. Y would be 1. 5 would be the second. X minus 7. X would be 1. 7 would be 2. And of course, they could look a lot more complicated, like 4x squared plus 3x. Of course, they could look more complicated. I know they're two separate terms because of the plus sign. One term, two terms. Life is that easy today. Okay, so it's trinomial is 3 terms. So I need 3 separate things. So I might have x plus y plus 2. 1, 2, 3. Or 4x plus 2y minus 6. 1, 2, 3. And of course, they could even maybe have a fancy exponent. So 2x cubed plus 4y squared minus 3. 1, 2, 3. There are 3 different terms. Okay, so we've got monomial, we've got binomial, trinomial, and then after that, there's not a cool name. They're just called polynomials. So if there's more than 3 terms, we just call it a polynomial. Okay, so my example is going to be, I'm going to write it sideways so it'll fit. B to the third plus b squared minus b plus 4. How many terms do I have?
4.
4. 1, 2, 3, 4. 4 different terms. Okay, so some non-examples. So obviously it looks like everything's an example, so we need to know what is not a polynomial. So a non-example would be if we try to divide by a variable. That's a non-example. What have we been talking about the past 3 or 4 days? What kind of functions?
Exponential.
Those are not examples. Those are not polynomial functions. When we're raised to an x power, it's called an exponential function. So that's not an example of a polynomial. Okay, are there any questions about the flap? What is a polynomial?
A polynomial. Oh.
Are there any questions about this first flap? Okay, well, I'm going to go over to the right flap that says, how do you find the degree of a polynomial? And what is the biggest exponent? So over here it says, how do you find the degree of a polynomial? What is the leading coefficient? Okay, the degree. That's a good question. The degree is the biggest exponent. The biggest exponent. Oh, I can. The degree is the biggest exponent. So, for instance, on our polynomial example, which is no longer on the screen, the biggest exponent was a 3, so our degree is 3. So, our degree, we're going to call it the degree of the polynomial, is our biggest exponent. So, in our example over here, I had b to the third. That's the biggest exponent I see. So my degree is 3. We'll work a few more examples. Hold on. And then the other question asks, what is a leading coefficient? And that's going to be the leading coefficient. I'm going to put LC because I'm out of room. That is the number in front of the biggest exponent. And if they don't write a number,
That's automatically 1.
it's automatically 1. The leading coefficient is the number in front of the biggest exponent. Okay, so potentially what they're going to do to trick us is they're not going to put it in highest to lowest order. They might have a degree 3, but he might be in the middle, and he's the biggest. So anyway, let's look inside the flap. If we look inside the flap, what is the degree of 9 to the x? What's the exponent? 1, and understood 1. And then what's the leading coefficient? What's the number in front of that? 9. Perfect. So we look at our next example. It says 2x squared plus 2x. What's the degree of... Oh, perfect.
Wait, I'm lost.
The degree, the highest exponent you see. What's the highest exponent you see on that line? 2. That's why the degree is 2. Okay, what is the number that goes with that x squared? 2. So the leading coefficient is a 2.
3. Is the next one 3?
The next one is 3.
I got it.
So the degree is 3, and what's the number that goes with it?
2.
The leading coefficient is 2, because the number in front is a 2.
Oh, and then it's going to be 3 and 15. I just can't 3 next.
Okay, so you get to the next one, and Ty's already caught on that the next one is a trick. Obviously, the degree is 3, but they wanted you to think it was 1, because 1 was in front, but the highest degree is the 3. Okay, and then what's the leading coefficient of that term?
1.
Negative 1. Thank you, Natalia. Not just 1, negative 1. Okay, are there any questions about any of this so far? Yes, on my desk it's blue. It's the little strippy kind. Okay, so now we need to talk about how to add and subtract them, and it's actually going to be really easy as long as we're careful. Okay, so on adding polynomials, I'm going to write some notes to myself before I get going crazy. My first note to myself is that you want to, as always in math class, combine what?
Like terms.
I'm going to write combine like terms. That's for the bajillionth reminder to myself. Combine like terms.
Yes, see.
Super zoomed in. Okay, but please remind me, what is a like term?
Like 2x and 2x.
What do they have the same?
The base.
The base or
The very
I'm going to say the same variable, but can you combine x plus x squared?
Yeah. Wait, what'd you say?
X plus x squared?
No.
No, because it has to have the same variable and the same exponent. I'm just going to put EXP because I'm out of room. You probably are too. Same variable and same exponent. So we can't combine x squared plus x. They do not combine. But we can combine x squared plus 2x squared. And so really, you've probably been combining and adding and subtracting polynomials for a long time. You just didn't know that's what we were calling it. I'm going to color in the side of my way. I can't help it. So when you open the flap, is everyone ready to go? Okay, when you open the flap, there are two examples. My first example says 4x cubed plus 2x squared plus 6x minus 4. What kind of, is that a monomial, a binomial, a trinomial? Tell me about this polynomial. This first thing in parentheses. How many?
Polynomial.
How many are there? Because there's 4. How many with the second one? So it's a trinomial. Okay, perfect. What's the degree of the first one? What's the leading coefficient of the first one? What's the degree of the next one?
3.
And what's the leading coefficient?
1.
Okay, so you already know some things. Can we combine? Is there anyone that can go with 4x cubed?
No.
He doesn't have a friend.
No.
He can't go with x cubed. You can't do 4x cubed plus x cubed. They have the same x. They have the same exponent. So it's going to be 5x cubed. Yes, I understand now. I'm sorry. I confused you. It's okay. It's allowed. Okay. And then I see 2x squared. Does he have a friend?
It would be minus 3x.
Okay, so he has the minus 5x squared. 2 minus 5 is a negative, so negative 3x squared. I know Natalia saw it, but let's say that again. 2 minus 5 is negative 3. Does anyone have a question about that second term?
This is kind of complicated.
Okay, now I get to the next one, and it's 6x. Does 6x have anyone he can combine with?
X.
What's 6x plus x?
7.
7x.
Okay.
4.
And then Natalia's already on it. Minus 4 has no friends. That does not mean he disappears. He just gets to come along. He can't get combined with anyone. I like to, when I do these kind of problems, the little underlinings I'm doing, I do on purpose to help myself. I know those two go together. That's why I put the same kind of squiggle. I know those two go together. That's why I put the one line. I know those two go together. That's why I put the 2 lines. Yes, ma'am.
So why would we combine the exponents if we combine
Oh. Why wouldn't we combine the exponents? When we add, are we allowed to combine the bases? Combine the exponents?
No.
We only get to add the exponents if we do what?
Multiply.
We're not multiplying right now. We're adding. That's a good question. We're not adding. We're not multiplying. We only get to combine the exponents when we're multiplying, dividing, or raising a power to a power. If we're just normal adding or subtracting, some people who missed it on their justification answer, if we're just adding or subtracting, you can't do anything to the exponents. That's a really good question. I'm glad Allison asked it because many of us tried to put x to the 5th plus x to the 2nd is x to the 7th on our thing, on our justification document, and we lost points on our test because we're supposed to multiply and add the exponents. Okay, my voice is going out and you leave me soon anyway. We'll stop right here. You don't have any homework. I'll give you the coloring page and we'll pick up from here tomorrow. If you, and you know who you are, if you have to have my signature today, come see me one at a time. I'll start with Allison. She raised her hand first.
Can I get you 0 period tomorrow?
You can. If yours is not till tomorrow, let me get the first priority would be the people who have to go today.
Oh, no.
I want to see the people who have to go today. Not many have turned in. I'm missing this for most people. Where is your exponential checkpoint? I need your exponential checkpoint.
I'm not sure if I can.
I'm ready to all creative classes except I'm taking regular chemistry.
Oh, you're going to check.
Anyone else who needs my signature today, bring it to me.
Yeah, everything creative except for chemistry.
Oh, I'm doing everything except for
I'm done laying up on
Your
this.
coach is not telling you I should say that.
Well, Coach Sherman told me that's not creative. No, I didn't. Oh, God.
Wait, are you saying it?
I really don't feel like having
Alice,
advanced for what?
I'm going to creative.
I'm just saying.
it's probably in the giant site. I just haven't created.
You will be right. I'm not.
Prior.
We don't have a lot of.
Alice, come here.
I don't like that. I figured out. I don't know. Allison passed them out. That's screaming. That's screaming.
My key.
Dad, you're ruining the day.
I need you to go with. I won't you. I only want you. Go look at it.
Where's the orange meat?
It kind of looks like a guy. I would trust you with those scissors. These scissors. I trust you more than I trust Catherine. My mom, Wolverine was like Jackman, and my mom is in love with him. That's my mom.
Who else wanted me? Tiana, this is yours, and then I have someone else. Emma's. You got it written down. I can't.
The bathroom, and then your dad was like, and I was like, he's so big. Your dad is so like big, but you're like, I get it.
Allison, you saw my
like
friend.
in spirit. Like when they come to you, I'd be scared.
Who else?
I'm like the heartbeat.
They are.
All he would have to do was just bam, and I'm like, he pokes me. He's like, he puts his finger up, and I'll start running.
I know.
Tara, these your color pencils?
No.
No, they're already there.
Where we're gonna do three. This is what I heard. Yeah, I like it. I think you should do that and that. I think.
Okay, so you're gonna try and tell me that they just make different kinds of soils, but you keep that.
This one would be more important than that one. I would say that maybe let's do this one created, and let's do this one created. That's I'm not geometry teacher, I'll not say that, but this will really help with that more so than geometry at all. So, yeah, you're the only person who I would say could do one, I think that would be good. When you explain to your parents that 2 gray B's are going to make you have gray hair, yeah.
That's what I've been telling. Like everyone's gonna have gray hair.
Yeah.
Sophomore.
I know you're determined. I know you can do one. I don't tell anyone else to do one. I'm only going to tell you that.
It's just competition.
Because, I mean,
How are you doing?
my voice is leaving me. I don't know why. Yeah. Hey, can you raise the screen and then find my remote and mute it? I'll find the remote. You raise the screen. I'm gonna get some water. Maybe that will help. No, I have that. I have any coffee. Bye.
Oh yes, there's the.
Oh, Aubrey had t-shirt money for me. Oh, crap. I forgot about last period. Hannah, say those words again in about 4 minutes.
Oh,
Thank you. You.
What are you?
Yes, you are. Now go.
Harm?
I only have ransom.
Oh, random.
Look, it's on the wall.
It's muddy.
Miss Esri asked if you have any extra.
Just the one. How many you should eat that?
Huh?
If I put on makeup, then I believe Santa.
Attention class. Justifications for points from this concept. There you go.
You put some exclamation marks on it?